All right, here are all those steps that we've just discussed on one big slide to show you guys the big picture and what's really going on from transcription to translation to end up or to go from nucleic acid, what was DNA, a gene, to protein. So transcription is going to be the step where RNA, specifically messenger RNA, is made from a DNA template. We can see that RNA polymerase is the enzyme that's involved in that process. This occurs in the nucleus. Step 2, as well, occurring in the nucleus, is RNA processing. We have addition of a cap, addition of a tail, poly A tail, to the mRNA, in addition to splicing out those non-coding areas known as introns. So the editing is done, and the mRNA then leaves through the nuclear pores and continues on. Step 3, amino acid attachment to the tRNA. This is getting assembled well before that mRNA is formed so that they're ready for translation to occur. Translation isn't happening just yet. Through different enzymes, we have tRNAs now attaching to their respective amino acids so that they can be carried and ready to enter translation. Step 4, now with the addition of mRNA coming in, and with the addition of these tRNAs that are formed, initiation of translation can begin. Ribosomal rRNA subunits are formed. There's my small at the bottom, that base-like structure. There's my large there in the back. That's going to hold the A site and the P site, which we can't see the letter P because that tRNA is already there. Codons on the mRNA are going to have a triplet reading that is going to be complement to the anti-codon on the tRNA. Now that guy knows which amino acid to bring based on the message brought by the mRNA, and translation has initiated. Next step, elongation. Elongation of that polypeptide chain. We now have new tRNAs entering the ribosome, knowing how to enter due to that A groove site in the back of the large ribosomal some unit, and knowing that they are the ones that are going to enter based on the reading of the mRNA, codon to anticodon. New amino acid comes in, it will form bond to the already existing polypeptide chain, and then eventually this tRNA will leave the site as that chain grows and new tRNAs are added. Next step, termination. Once a stop codon has been reached, that is going to determine the termination of the protein making process and stop. Now we have a polypeptide or protein at the end of translation. Not forgetting our essential dogma, it's important to remember the bigger picture here. That previous slide did show you that big picture, but if we kind of just sum it up with even less images, we have, whoops, let me show that next. We have going from DNA to mRNA that occurs in the nucleus, that is transcription. Now we have mRNA to protein, that is translation, that occurs in the cytoplasm. Rough endoplasmic reticulum is important here. It's the next organelle that I want to talk about. And remember, I taught you guys during the cell lecture that the rough endoplasmic reticulum is like the Amazon warehouse of the cell. Its job is to basically get those proteins that are made, package them into nice little vesicles, and ship them off to wherever they're going to. Here I can see a ribosome, and it's going to make a polypeptide chain eventually. There's translation and products. And remember, a lot of ribosomes are located already on the endoplasmic reticulum, the rough endoplasmic reticulum. Well, that's great because it can take the product already there to the warehouse, the ER, where it's going to go ahead and get modified, shape. I'm talking about the protein's shape here, with a little other bits of edits that occur. Proteins are then secreted into transport vesicles. They're packaged up into nice little vesicles in the endoplasmic reticulum. The vesicles bud off, and they are secreted to wherever they need to go, whether that's in the cell or outside of the cell.